So chapter 6, circular function. Well, this chapter is the last chapter for kind of half revision and a little bit new things. Well, maybe not half. Almost everything is revision. There's only a little bit like which is extended a little bit more. So for circular function, it's a very important topic, okay? Because it's not a good time to learn it, it's just through the sec. So I haven't teach last week. So this week I need to rush through everything. But it is a very important topic. Definitely in the exam, I think one exam response question will relate to circular functions. So like that's always like that. Like one big question will about circular functions. Also, multiple choice questions will involve a lot of circular functions as well. I just quickly go through what you need to know, and I will focus on the part like most of the student cannot do. So, well, first exercise is talk about the change between degree and radians. Well, like what you need to remember is degree to radian form and radian form back to degree. Well, first of all, in your calculator, make sure you keep things in the radian form. See here, like keep it in the radian form. Do not make it into degree form. You know, like most of the questions will use, well, not most, like 99% of the question will use radian form. So if, for example, you see something in degree, okay, you see something in degree, you can get the degree button from the pi. See the degree button here? You can, for example, I want like sine, okay, for example, I want sine 30 degrees, but it's your radian form. If you type nothing here, that will be 30 radian, not degree. But if you go for pi and type the degree here, that will give you a half. Okay, that will give you a half, which means you can use degree in the radian form as well. Well, it's the other way around as well. If you keep in degree and you put the C for radian, you can still work on radian. But because most of the questions will use radian form, so keep it in the radian. I know students from year 12 who set into the wrong setting in exam and then can't do anything. Okay, it's definitely can't do anything. And then she realized it like after about 30 minutes, like, oh, I can't work out this. Like after 30 minutes, I'll realize that's not in the radian form. So that's a really bad thing. Make sure you check your calculator. Also set that in the default, make it default, like when you open it, that will be radian form. That's the most important thing maybe for this exercise. Well, degree change to radian, I will times pi over 180 because pi is 180 degrees. And radian back to degree, I will times 180 over pi. Okay, so something like this. So that's the first thing. And the next thing is, well, I'm not going to go through what's a radian, like why we come, how that come from. Like I'm not going to talk about that. The next one is talk about unit circle. So unit circle is help you to define what is sine, what is cosine, and what is tangent. Like that's the definition for sine, cosine, tangent. You know, sine, cosine, tangent is not only using angles in between 0 to 90 degrees. It can be any angle for sine, cosine, and tangent value. So how we define that is we're using unit circles, and we have the, well, I said that's cast, C-A-S-T, from the fourth quadrant. But like I know another teacher like teach this, say like they start from the first quadrant, it's ASTC, right? They said it's all station to confuse. Like that's how you remember that. So that's the cast, or like all ASTC, which means which trig ratio is positive in that quadrant. So in the first quadrant, everything is positive. In the second quadrant, everything sign is positive. Also, like the definition for that is you draw the unit circle which center at 0, 0 with a radius of 1, and then you draw the angle. The angle is measured from the positive side of the x-axis, and I go for anti-clockwise to measure it. If I go clockwise, that will be the negative angle. So we make intersection with the unit circle for a particular angle. Then the intersection, the x coordinates means the cosine and the y coordinates means the sine. Well, it's not really helpful to know this because you can't find out intersection by yourself. But the only use for unit circle is to define the angles which is multiple of 90 degrees. So when the angle is multiple of 90 degrees, for example, 0, 90, 180, 270, like pound to 3 pound to like 2 pi, those angles will be on the x-axis or on the y-axis. Now you know what the exact intersection is. For example, the exact intersection. Okay, for 0, that will be 1, 0. For that is 0, 1. For that is negative 1, 0. And for that one is 0, negative 1. Okay, so what this used for? The unit circle is only help you to find out the sine, cosine, and tangent values for multiple of 90 degrees. So when you have 0, you see the intersection. The intersection is 1, 0. X represent the cosine value and y represent the sine value. So sine 0 will be 0, cosine 0 will be 1. How that come from? That from unit circle. So that's the only use for unit circle, is help you to find the ratios for those angles. So tan will be top divided by bottom, that will be 0. Then I have that is 0, 1. So top divided by bottom, that's undefined. So for pi, I have negative 1, 0. We have that is 0. And for 3 pi over 2 is 0 and negative 1, and that's undefined again. Okay, that's undefined again. So this is unit circle is used for what? Is used for this. Also is used for explain why we have the cast, like the CAST thing. We understand that? That's alright. So, well, evaluate the following. I'm not going to evaluate all of it for you. I'll just maybe evaluate one, like say B, cosine negative pi over 2. So where is negative pi over 2? Negative pi over 2 is go this way, and the intersection is here. So that intersection is 0, 1. And you know x value represent the cosine, so that equals to 0. So that's how you use unit circle. That's just an example. Don't have time for you to just go through everything. You go practice that and I'll provide solution for you. Okay, so that's like all these questions are used unit circles. So that's this exercise. And the next exercise, well, let's skip this to page first. Let's go to see page 5. Well, the box is a little bit too small. Okay, so another, well, this is called, well, what we do for the 90, 180 degree, like they are the special angles, because the angles can give you an exact form for sine, cosine, and tangent ratios. They are called special angles. There are two types of special angles. The first type is the multiple of 90 degrees, which is the angle on the x-axis or y-axis. But there's a second type of special angle, which is the reference angle give you 30, 45, and 60 degrees, which is pi on 6, pi on 4, and pi on 3. So what's a reference angle? Well, you know reference angle is when you sketch the angle. For example, let's sketch 5 pi over 6. So this angle, 5 pi over 6, will be here. Okay, that's a 5 pi over 6. So go from the positive x-axis and go anti-clockwise. Another thing I want to say is, why your leg pass looks different? Oh, okay. Just interested in that. That's fine. 5 pi on 6. I know a lot of students convert things first and then sketch. Well, for her example, this one student will convert that into, okay, pi is 180 divided by 6, I got 30. 30 divided times 5, 150. Okay, 150 will be here. That's too slow. Okay, that's too slow. You need to get used to the reading form. So how I think about this question is 5 pi on 6 is about 1 pi. Okay, 1 pi is here. How much is less than 1 pi? Is pi on 6 less than 1 pi? So you know what's pi on 6 is about 30 degrees. So that angle will be here. Okay, that angle. That's how I remember this. The worst one students can't do is 2 pi over 3. Hard to think. Okay, where's 2 pi over 3? Or 5 pi over 3? Or let's say 5 pi over 3. So 5 pi over 3 is about 2 pi. Okay, is about 2 pi. But is pi over 3 less than 2 pi? So this angle will be here. Okay, this angle will be here because it's not 2 pi yet, but it's reaching 2 pi. So pi on 3 away from 2 pi. So that's the 5 pi over 3. But anyway, that's just how I sketch angles. Like, do not convert into degree, it's too slow to do. Now come back to what is reference angle. Okay, what is reference angle? When you sketch this angle, then it will make a smaller, like an acute angle with the x-axis. So for example, this one make an acute angle with the x-axis, which is here. That angle is pi on 6. That is called the reference angle. Okay, that is called as the reference angle. So that is the reference. So any angle with a reference angle of 30, 45, and 50, 60 degrees, they are special angles as well. We can directly evaluate them. Okay, we can directly evaluate them. So before we know how to evaluate those angles, let's think about the ratios for 30, 45, and 60 degrees. I know students can't remember this, okay? I see most of students can't remember. For example, I ask you, what sine pi on 6? Most of you will think for a while, like can't directly tell me. So when you think about it, you waste your time. So if you really can't remember those ratios, you can't tell me in a second, what you can do? You can draw this table in the exam at the beginning. Okay, then every time you want to find some ratios, go to look at your table, like you draw it somewhere and you go back to think about it. How to set up this table? It's very easy to set up this table. So first of all, you write things in order, like the row is 30, 45, and 60, and the column is sine, cosine, and tangent, exactly right in that order. So the top row, like the first row, will be root 1 over 2, root 2 over 2, and root 3 over 2. It's very easy to remember. Okay, root 1 over 2, root 2 over 2, and root 3 over 2. Then the second row is the backwards. Is the root 3 over 2, root 2 over 2, and root 1 over 2. Well, root 1 over 2 is a half, like it's 1 over 2. So that's how we remember, like how I can set up this table in 30 seconds or even 10 seconds. Just write it down. Then you know tangent is sine divided by cosine. Okay, it's the sine divided by cosine. So for tangent is 1 over root 3, and then the middle is 1, and then it's a root 3. Okay, it's with patterns, 1 on root 3, and then 1, and then root 3. It's very easy to remember. Oh well, you should know 1 over root 3 is root 3 over 3. Okay, it's root 3 over 3. So you need to convert that. But when you remember, you can remember the 1 on root 3, and then you convert it later. So think about that. You know the pattern. You can draw this table 10 seconds. Yeah? Because I see a lot of students, when I ask them, like, oh, what's sine pi on 3? They just sit there and think forever. Okay, just think forever. They're not trying things. They're just trying to think. If you can't remember, you can't think. Okay, find some way to help yourself, and you can tell me as quick as possible. So that's the best way to do it. Okay, it's just how we find those ratios. We're using right angle triangles and the isosceles right angle triangle, and we use the equilateral triangle. So I can cut that into half. I got the 30, 60, and 90 degrees. I know that's 2, that will be 1, and Pricetag, that will give me root 3. And then I can work out the sine, cosine values. But I'm not recommending you to remember the triangle. It's still too slow to do it. If you know the table, directly go for it. Okay, directly go for it. So this 45y is the same. So 1, 1, root 2, and you can find sine, cosine, and tan 45. Now, when you know this table, when you know the special values, let's talk about how to find the values, how to find the trig ratios for the angle which got the reference angle of those 3 values. So think about cosine 5 pi over 4. Okay, 5 pi over 4. Again, do not convert it. You know 180 divided by 4 is not that easy to do, and then you further times that by 5. It's hard. So what I would think about is, what's 5 pi over 4? It's pi plus pi on 4. Okay, pi and a bit, pi at plus pi on 4. So the angle, first of all, we will sketch the angle. Pi is here, and then go further pi on 4. You know pi on 4 is a 45 degrees, so that will be here. Okay, this is the angle that is 5 pi over 4. So I know the reference angle will be that one. Is the line made with the x-axis. Okay, it's the line made with the x-axis, and that's a pi on 4. You just draw it, that's a pi on 4. It's pi and pi on 4. Okay, what whose quadrant is this one? Like the CAST, that's the tangent quadrant. Okay, that's the first two things you do when you're trying to evaluate values. Okay, next. We will think about, okay, the first thing we'll do is we draw this angle here. And then the next thing we do is we change the larger angle to a smaller angle. The angle you need to change to is the reference. Okay, is the reference. So you change that to 0.4. That's definitely a positive value. Can you think about that? Like sine, cosine, tangent 90 degrees is definitely a positive. So you change a big angle to a small angle, that definitely got a positive. Now you need to decide, is this actual ratio should be positive or negative? You know that's the tangent quadrant. You're talking about cosine, that's definitely negative. So we will add a negative sign in front of that. That's the two things we'll do to evaluate the trig ratios. Change the angle to reference and then decide it's a positive or negative. Now you know cosine pound 2 is root 2 over 2 by the table above. So that's a negative root 2 over 2. That's how you evaluate that. Let's evaluate another one. Let's evaluate this one. Sine 150 degrees. Okay, sine 150 degrees. Well, I know sine 150 is here. Okay, that's the 150 degree. This is the sine quadrant. I know this reference angle must be 30 degrees. First thing, I'll change the big angle to a small angle into the reference, which reference angle is definitely the angle in between 0 to 90 degrees. Not negative, only positive, 0 to 90. Then this is the sine quadrant. Sine will be positive. So it's a positive. Okay, it's a you don't need to write the positive, just let me know, like it's a positive. So that's a positive a half. Okay, that's a positive a half. Okay, I have talked about two types of special angles and how we evaluate that. Multiple of 90 degrees, that's the angle on all the x-axis and y-axis. The second type is when the angle got a reference for 30, 45, and 60. That's another way, another thing we do. Okay, knowing this, let's go to the top. Page 3. Okay, for page 3, well, we have the symmetrical properties. Well, we never remember the symmetrical properties. We always see the graph. So think about where's pi minus theta. If theta is an acute angle, okay, if, like, let's assume, make the assumption, theta is an acute angle. Pi minus theta must be in the second quadrant. Okay, that's how I remember. It's not actual a proper proof, but that's how I remember that. So we assume theta can be anything. Okay, remember theta here belongs to anything, like any angle. But let's assume, because it's true for any angle, I can assume it to be any angle. Okay, I assume it's an acute angle. So pi minus theta must be in the second quadrant. And also you know that's the sine quadrant. That's the sine quadrant. And also you know the reference angle must be theta. Well, it doesn't matter what's the theta, but the reference angle will be theta. So sine pi minus theta is a big angle. I will change everything to the reference angle. Well, it doesn't matter sine pi minus theta or cosine or tan pi minus theta. I change everything to the reference angle. Now, only sine will be positive. So sine will be positive, the other two will be negative. That's according to what we do when we go for page like page 5 or something like that. So only sine will be positive, the other two will be negative. Then the formula you have is cosine pi minus theta is negative pi minus theta. It's the minus sine cos theta. Okay, it's the minus cosine theta. Now think about pi plus theta. Okay, pi plus theta is pi and a bit, which is here. Pi and a bit. So the reference angle again will be theta as well. Okay, But this is the tangent quadrant. This is the tangent quadrant. So what we have is sine theta, cos theta, and tan theta, and only tan positive, the other two will be negative then. And the next thing we have is 2 pi minus theta and minus theta. So 2 pi minus theta and minus theta, they are equivalent. They are the same. Why they are the same? It's minus theta plus 2 pi. You know, like any angle plus 2 pi will still be the same angle. Okay, same place. Like add 2 pi, go another cycle, that will be the same thing. So they are the same angle. Okay, they will have the same place. So where's minus theta? Minus theta or 2 pi minus theta will be here. Okay, go a little bit that way, or 2 pi not reaching 2 pi, and we minus theta. So the reference angle is theta. I'm not talking about the actual angle, I'm talking about the values, okay, the acute angle, the positive angle. So it's theta. This is the cosine quadrant. Well, they are the same, so they will have the same thing. I'm not going to write it twice. So it will still be sine, cosine, and tangent, but because tangent, cosine is positive, so negative, positive, and negative. That's what we will have. Questions? Okay, no questions, keep moving. That's what we know before. Example 2 is just using all the things above, like too easy, not going to talk about that. Next page is important because I feel more and more, well, before 2016, no one really focused on those formulas, but I realized these years more and more questions focusing on those formulas, which is harder than the previous page. So the first is the complementary relationship. What's complementary? They add up to 90 degrees, like pi on 2. So what we have is sine pi on 2 minus theta will be cosine theta. Why is like that? Theta, here theta can be anything as well. Okay, not only within 90 degrees, but it can be anything. But let's still assume theta is in between 90 degrees. Okay, acute angle. So what is that? Let's draw a right angle triangle. Don't like that one. Okay, if I say this is a right angle triangle, if that's a theta, that will be pi over 2 minus theta, right? That's the two angle. So theta is this, pi 2 minus theta is that. Let's see this is a right angle triangle. Again, this is the way I remember it. It's not a proper proof. Okay, not the proper proof. What I will do is that's A, that's B, that's C. So let's think about what's cosine theta. Cosine theta will be B over C. Okay, B over C. What is sine pi over 2 minus theta? That's B over C as well. Okay, use the triangle here. Okay, use the triangle here. That's B over C as well. So what that shows you, they are equivalent. Okay, they are equivalent. Sine pi over cosine theta equals to sine pi over 2 minus theta. They are the same thing. Okay, they are the same thing. That's how I remember it. So sine theta is the sine value opposite over the hypotenuse for the opposite, and then the cosine pi over 2 minus theta is the adjacent, which is the same line over the hypotenuse. So same as that one. Okay, you can prove it using the same thing. Cosine pi over 2 minus theta is A over C. Sine theta is A over C as well. Equivalent, so that's the same thing. Okay, that's how I remember this formula. This is very important. Okay, this is very important. Also in transformation, we sometimes use this as well. We'll talk about transformations later after I finish this exercise. It's a quite complex question, but that's you can use this formula in transformation as well. Give your example, like if you have what you can write this down and then think about it. Okay, think about it. I'm not going to go through this today. So how sine theta has been transferred into y equals to 3 cosine 2 theta plus pi of 3 plus 1. Okay, how that graph transferred into cosine graph. I said the transformation is not going to change the equation of the formula, the type of function, but sine cosine is the exception. because the graph looks identical. They all have the waving graph, so they can transfer between each other. So that's the hardest type question for transformation, and we use this formula to solve for that question. Think about that, how you can solve for this. I'll come back to this later. Now the next one, well, that's the pi over 2 minus theta. I can still use a right angle triangle to represent the situation for you. But the next formula is not that easy. It's pi over 2 plus theta. It's over 90 degrees now. Okay, it's over 90 degrees now. It's not that easy to think about. So what we will do is, let's sketch pi over 2 plus theta. Okay, pi over 2 is the 90 degree plus theta, which is here. Okay, this angle is pi over 2 plus theta. So this angle here is theta. Cannot give you time to think about it. I really don't have time. So I can see the reference angle is here, right? The reference for pi over 2 plus theta is there. And this angle is pi over 2 minus theta. Okay, that's the reference. That's the reference angle. It's not theta. Theta is here in the vertical, but the what is called reference is the horizontal one. So it's the pi over 2 minus theta. So what I can do, well, I'll show you the first one. I can show you the first one. Sine of pi over 2 plus theta. I can, well, this is the sine quadrant. I can change that to the reference angle. Okay, change the big angle into the reference. And because sine is positive in here, so I have positive. Yeah? And you know sine pi over 2 minus theta is the cosine theta. That's the thing we get from the above equation. So that's why sine pi over 2 plus theta equals to cosine theta. Again, it's not a proper proof, but that's how you can remember it, how you can get it done. Okay, how you can get that done. Okay, for the cosine one is easy. Well, let's not think about this side yet. Cosine pi plus 2 over pi over 2 plus theta, I can change into reference angle. But you know that's the sine quadrant. Cosine will be negative. Cosine will be negative. So it's the negative cosine pi over 2 minus theta. And you know that's minus sine theta. And that's how we get the right hand side. Okay, that's how we get the right hand side. Not a proper proof, but that's how you can remember and how you can work it out. If you forget about it, like in the exam, I can't remember the formula. Well, if you can just remember the formula, okay, don't worry about the proofing. Okay, don't worry about how you can get it. Just remember it, use it. But if you can't, that's how you can figure it out. Okay, if you see cosine pi over 2 plus theta, oh, what is it? Then you can work out that by using this. Okay, that's another two other new formulas here. And the last formula we have is the Pythagorean identity. Okay, it's the Pythagorean identity. So the Pythagorean identity, well, go for a little bit extension, okay, just a little bit for special student. Well, for master student, it's alright. So let's draw a hexagon. This is helping you how to remember formulas, only for special student, okay? This is a hexagon. So I write sine, cosine, tangent in these three places first. That's all the things you need to remember. And remember, 1 is in the middle. Okay, 1 is a magic number. 1 is in the middle. And what's the other three things is the 1 over. Okay, it's the 1 over of that. It's not the inverse, it's the reciprocal. So cosine 1 over cosine is the sec. Sine 1 over is the cosec. And tan is the cotan. Okay, so that's, I set up the hexagon first, and I can see 6 triangles here, but only 3 of them is useful. So the 3 triangles you have is the triangles upside down. Okay, like this shape. So you can shape those 3 triangles up. Okay, each triangle here represents a relationship. So the 3 things. The first triangle, okay, the first one, this triangle, what that gives you is the horizontal 2 add up will give you the bottom. So it's the sine square plus the cos square equals to 1. Okay, that's the relationship you have from the first triangle. The next triangle, you can do the similar way. So the horizontal 2 will add up, give you the corner. So it's the tan squared plus 1 give you the sec squared. That's how I remember. I never remember this formula. I always see this hexagon. And then the last one, horizontal 2 will give you the corner. 1 squared plus cotan squared give you cosec squared. I know you have those three formulas and it's very hard to remember which one plus 1 and equals to which one. So that's how I remember it. Just a little bit helpful you if that can help you. Just you can use this to remember these three formulas. So come back to method. We only have the first triangle there. Okay, sine plus cosine give you the corner 1. So tan plus that give you the corner. 1 square plus that square give you the corner. So that's how I set up the three formulas here. Okay, when do we use this? Okay, this is so important. Okay, when do we use this? When do we use sine square plus cos square equals to 1? For any angle, if I give you any one, sine or cosine, you can work out all the rest. Okay, you can work out all the rest. So how I can work out all the rest? C cosine theta equals to negative 0.4. So that's a negative 2 on 5. I like fractions. Okay, I like fractions. So I know cosine. I want sine. This is the time we use the Pythagoras identity. So sine squared plus cos squared will give you what? That's what you know already. But what I want to talk about is how you can write a correct working. Okay, how to do the correct working. So sine squared theta plus, you know, cos squared is minus 2 on 5 squared equals to 1. And sine squared theta is 1 minus 4 on 25. That's 21 on 25. Okay, after this step is important. What's sine theta? You must write the plus minus value, okay? That's plus minus root 21 on 5. I know you can only take one because for one angle there's only one ratios, okay? Only one angle give one ratio. It can't be plus minus. I know that, but you need to write plus minus at this stage. Then we decide, because theta is in between pi and 3 pi over 2. It's in between that. Where is it? It will be this quadrant. Only tangent is positive in that quadrant. So sine theta will be negative. You make the discussion after plus minus. So you make the decision. Sine theta is negative root 21 over 2. This is a full working. Okay, you gain full marks, you need to go through the full working. You need to write every single line here. I know that there's another way to talk about it. I'm not going to go through that. I think it's a little bit confusing for most of the students. So just remember this way. When you get sine, how you can work out cos. When you get cos, how you can work out the sine. But remember, you can't have both. You can't have the plus and minus. You need to make the discussion after that to say whether it's positive or negative. But you need the discussion bit. And when you get, yes? This one? That one? Very important. Yeah, important. Like it's just a sign to say it's important. Yeah? Yeah, sorry. How again? 2, 5, 5, 5. See, that's how you make mistakes in your test. Just copy things wrong. Again, when you get, well, when you know cos, you can work out sine. When you get sine, you can work out cos. And then how we can work out tangent? Tangent will be done by sine theta over cos theta. That's the formula you must remember. Oh, I forgot to talk about that in the previous case. Okay, anyway, that's very important. So sine is root 21 on 5, and I'll divide by negative 2 on 5, which is 0.4. and that gives you root 21/2. And you can see I get a positive value here, and I should get a positive value because it's the tangent. Questions? No? Okay, and then it's use the formulas for the next 4, but you just use the formulas of both to work out things. I know sine, cosine, tangent already, so everything's easy after that.